All right, guys. For today, did not want you to have to learn this on your own tomorrow. Okay. So for today, I'm going to go over with you. We're doing 5.5 and 5.6 combined. You won't even notice that I combined two sections, but that is two sections together. So what we're going to work on today is part one. There's two different parts to this. We're going to find the number of solutions. I actually have taught you that from like day one, so that part's real fast. Find the zeros of a polynomial function. What's it mean to find the zeros? I'm finding the what? The answers, the solutions. I'm actually solving today. And you're like, I already know how to solve. Why am I spending a whole day on this? Because everything I've given you so far, you notice I've always given you one of the factors? I'm not giving you one of the factors today. Yay! Aren't you excited? I knew you'd be excited. All right. So, first part, the fundamental theorem of algebra. That sounds fancy, doesn't it? Do you know you already know what it is? See all those crazy words and all that in there? I'm not even going to read it. You guys know this. How many solutions does this problem have? How many does this one have? Great. That's the fundamental theorem of algebra. Moving on. You already know that. Part of 5.5, yeah. But you guys already know that. So, all right, great. Moving on. We've learned this already. What does it mean when your graph looks like that? Okay, it's an even, it's negative. What do we know about the answers to that graph? Where does it cross the x-axis? 1. And since it bounced off of it, what does it tell us? Yes. It means 1 is an answer twice. So if I asked you what does x equal, you'd be like, well, x equals 1 and 1 because it bounced off of it. Remember that? We talked about that a little while back. If it bounces, that answer shows up twice. Right, 2, 4, 6, usually twice, but yeah. Okay, so the problem that we have is that factoring can sometimes be very difficult when our methods don't actually work. Right, we've learned a lot of methods for factoring, right? We have GCFs, we have, you know, the options for A, options for C, we have the quartic ones, which are x to the fourth, you have sum and difference of cubes, your SOAP pattern, you have grouping. But what if you try all of that and it still won't factor? How do you solve it? This is where your graphing calculator becomes your best friend, okay? So we are going to have to find at least one of the factors, depending on the problem, and then we're going to, using synthetic division, we're going to get it down to an x squared so that then I can either factor it from there or use the quadratic formula. Okay, that's our goal. So this whole bottom part here, I used to always give you one of the factors. We did synthetic, and then we factored from there. Now I'm not giving you anything. Just the problem. I need you to solve it. The rational root theorem, this is how you do it by hand. And when I taught in Findlay, I taught the Advanced Algebra 2 class there, and I made them do it by hand. I taught Advanced Algebra 2 in Findlay. Yeah, I taught in Findlay for 10 years. But yeah, so I always made them do it by hand because they're my advanced students. They did it by hand first, and then I showed them the calculator, and then they hated me because I didn't show it to them from the beginning. But since you guys, I have with you such a short amount of time, we're not going to waste our time doing it by hand. And let's be honest, if it's me and I'm working through a problem, I'm going to grab my graphing calculator. I'm not going to do it by hand. Okay. I may briefly kind of show you quickly like the process just so you can have an appreciation for your calculator, but I will not ask you to do it by hand. Okay. We're going to use our technology. All right. So here we go. Find the rational zeros of that problem. Now, normally if I give you something and I ask you to solve it, your first go-to is to factor it. How many terms are in that problem, though? There's 5. We don't know how to factor something with 5 terms. So we can't factor. That's not an option. Okay, so what we need to do is we need to graph it. Okay, so let's go ahead and graph this equation for me. In your graphing calculators, I don't know if you've already done it or not. Remember, it's the second plus, second plus 7, 1, ooh, not 5. Ooh. Let's quit that. I hit the wrong button. Second plus 7, 1, 2. There we go. All right, so let's go ahead. How do we get to the part to make it graph? Y equals hit your y equals, and we're going to type in the equation. So we have x to the fourth. Remember that little caret button moves your cursor up to the exponent? Just make sure you don't type the entire problem as an exponent. Okay, make sure you drop your cursor back down. So x to the fourth minus x cubed. Drop your cursor back down. Plus x squared minus 3x minus 6. Double check before you hit graph. Make sure you look at it. Make sure it looks like it's supposed to. That you have minus signs, not negative signs. You don't have the whole thing written as an exponent. You get some funky graphs when you do that. All right, and then we just hit graph. Good. We knew both ends would be up because it was even, right? And we knew the whole graph would look something like that. We knew that. But what we're looking at today is where does it cross the x-axis? -1 and 2. Now, how do I know for sure that's where it crossed and not just it kind of looks like it? Say what? I can use the table. Yeah. So it looks like it's crossing at -1 and 2. So if I look at my table, remember that second graph that pulls up your table? If I look at -1, 0, 2, 0. So it did, in fact, cross at -1 and 2. Okay? So let's go back to our notes. So I know for sure that it crossed at -1 and 2. So first thing I would do, make a note. X equals -1 and 2. So how many answers does this problem have? It has 4. You just found 2 of them. I only got 2 more to go. Okay, so let's go ahead and try to find the rest of my answers. So once I know 2 of them, now we found the nice zeros, right? They're not decimals, they're not craziness, they're nice. We're going to use synthetic division. Okay, so let's set up our synthetic. Is anything missing from here? Nope. So 1, -1, 1, -3, -6. Now, it does not matter which one you do synthetic division with first. Doesn't matter. The first one I have written down is -1, so that's going to be the first one I use. And again, that's x equals -1, so I don't have to switch this on. Okay, so let's do synthetic with a -1. Drop down the 1. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. Now, what happens if I do my synthetic division and I don't get a 0 at the end? I did it wrong, or it really wasn't an answer. Because if you're somebody that just glances at the graph and didn't check it in the table, and you're like, yeah, that's got to work, and then you do your synthetic, you're like, whoa. Either your synthetic, you messed up somewhere, or it really isn't an answer. So you may want to go back and double check your graph. Okay. Now, this started x to the 4th. Where am I at now? I'm at x to the 3rd. But in order for me to be able to use the quadratic formula or factor it as easy as possible, I want it to be an x squared. Your goal is to always use synthetic to get you down to an x squared. Keep using it until they actually die. Sometimes that'll stay on for like another week. So we did synthetic once. Guess what? I got some double-decker synthetic going on. I'm going to use where I just left off, and now I'm going to use the 2. Okay? So I did synthetic. There was the answer I got. I'm going to do synthetic again on my new set of numbers. Okay? I used the -1. Now I'm going to use the 2. So same process. Drop down that first term. Multiply. Add. Multiply. Add. Multiply. Add. Do I need to worry about the 0 thing over here? No, I don't need to worry about that. So I got a 0 for my remainder again. So that means it is, in fact, a factor. So if I started x to the 4th, and I did synthetic twice, I'm now down to x squared. So I have x squared plus 0x plus 3. And I need to solve this, so we're going to write equals 0. Do I need the 0x? No, I don't need the 0x. So really, I have x squared plus 3 equals 0. Does that factor? How does that solve? not difference of squares. I should use the square root method. Right? So I'm going to subtract 3. So x squared equals -3. We'll take the square root of both sides. So what does x equal? Plus or minus I radical 3. -1 and 2. Of course. That stuff follows you all year long. All right, how many answers did you find? I found 4. Now, did you know by looking at the graph that there was a really strong possibility that the other 2 answers were imaginary? Because how many times did it actually cross the graph? It only crossed twice. Imaginary answers don't cross the graph. So I knew there was a pretty good possibility that they were actually imaginary because they didn't cross. All right, how are we doing so far? Glad that I didn't make you learn this on your own? That was just from looking at the graph. It's where it crossed the x-axis. Yep, those are my original ones I started with from graphing it. All right, let's try another one. So, find the zeros of that big long thing. Can I just try to factor it from the beginning? No, there's 5 terms. I can't even attempt it. Okay, so again, let's go to your graphing calculator. Go back to y equals. Clear out what's in there, and let's type this one in. All right, be very careful typing them in. Make sure you type it in correctly. You type it in wrong, you're in big trouble. All right, how many answers should I have? I should get 4, right? This problem has 4 answers. But it only crossed the x-axis twice. So what do I know that's probably true about the other 2? They're probably imaginary. Is it possible, though, since it crossed, that answer could show up 3 times? Yeah. Now, if it bounces, that means that answer shows up an even number of times. But if it crosses, it shows up an odd number of times. Okay? So just something to kind of keep in mind. All right. So where does it cross? -2 and maybe? Do we know for sure? It's not 0. It definitely didn't cross at 0. The table says -2, 0. That's just confirming that it did cross there. All right, so we know -2. Is there a way to get my calculator to tell me where that's crossing so I can determine if it's a nice answer or not? Right, like if it's a fraction, like half, 1/3, I can deal with that, right? But if it's like a decimal expansion that I don't recognize, that means it's probably a radical. So can I get it to tell me exactly where that point is? I can. Don't use trace. Don't use trace. Trace will like bounce and jump. It's not going to be nice. It is calculates. Very nice. So guys, look up here. You may want to make a note in your notes if you're not going to remember this, okay? See on your top, remember all this stuff at the top that goes with the graph. Above trace, don't use trace. It says calculate. So let's hit second trace to get it to calculate for me. What do you want it to calculate? The 0. Yeah, so choose option 2. Now, here's where if you're going to struggle at all with this process, it's going to be right here. Your calculator needs to know what you want it to look for. So it's asking you left bound, question mark. So I want it to go, this is the point I want it to find, right? Right over here. So if I'm looking at that, is left of that below it or above it? Think about if you're drawing it, right? We draw from left to right. We write from left to right. So as I'm drawing this from left to right, where is the left side of that? It is below. So this cursor needs to be anywhere below that point. Okay, so my cursor showed up right there. It's totally fine. So all you have to do is hit enter. And then your calculator says right bound. Because it needs to know where do you want me to look between. Your calculator needs to know where it wants you to look. Okay, so right bound. So where is to the right of that point? It is above it. So you're always going to move the cursor either below or above the x-axis. You're kind of like narrowing and, hey, look in between here is what you're trying to tell it. Okay, so I'm going to hit the right arrow until it jumps onto the right side of it or above it. Hit enter, and you will see the stupidest feature of your calculator. I honestly cannot tell you why on earth this feature even exists. Do you want to guess?
Yes.
Why would I want to guess? I'm asking you to calculate it for me. I don't understand why this is here. Just hit enter. It does not matter what is on there. I don't know why it even does that. And then it will tell you 0, and it tells you what the answer is. What is 0.3 repeating? That is 1/3. Okay? Now, the one nice thing is, if you're going through this process, and again, you only have to do this if you can't tell a nice, pretty one by looking at it. Most times you can just tell what they are. But if not, this is your process you want to take. If you mess up left and right, if you're like, gosh, I have no idea what she's talking about. I don't know which one's left, which one's right. If you flip-flop them, it gives you an error. So, hey, try it the other way. Okay? One's above, one's below. All right, so we know it's at 1/3. So let's come back to our notes. So we found x equals, what was the first one? -2. And then we found 1/3. Those are the two that we found. All right, so let's set up our synthetic. So 3, 17, 30, 12, -8. Again, always checking if anything's missing. In this case, it's not. So it doesn't matter which one you start with. I'm going to start with the -2 because it's the first one I wrote down. Drop down that 3. Let's do our synthetic. So we multiply, add, multiply, add, multiply, add, multiply, add. And I got a 0 at the end, makes me happy. I know there's no remainder. That is, in fact, an answer. All right, I started x to the 4th. I did the synthetic once. Where am I at now? I'm at x cubed right now because I only did it once. But I have another number that I can use now to go again. Yes, it's a fraction. You'll live. All right, so when we multiply, what's 1/3 times 3? 1. And then we add. We get 12. What's 1/3 of 12? 4. We add, and we get 12. What's 1/3 of 12? 4. And that's 0. No pain and suffering. Nah. Usually the fraction ones, they turn out pretty nice like that because they should end up nice. And you're not going to want to factor something with a fraction, so they won't end up fractions. All right, so I started x to the 4th. I did synthetic twice, so I'm down to an x squared. So 3x squared plus 12x plus 12 equals 0. Because I know I need to solve this. Okay, this looks like I should be able to factor it. So let's go ahead and try to factor. What's the first thing you want to do? GCF, take out a 3. X squared plus 4x plus 4 equals 0. Is that going to factor further? Good. It's going to be x plus 2, x plus 2. Does baby brother give me an answer? No, he does not. There's no x with him, so he's not an answer. So x equals -2 and -2. And what was the other answers we found? -2 and 1/3. Hey, wait a minute. So did any of those end up imaginary? It crossed. So that's possible. It shows up 3 times for an answer or 5 times for an answer. So in that case, it was 3 times. But I have no way of knowing that just by looking at the graph. Doing all right? Sure. Not too bad, right? We're getting there. We're using synthetic division, Ethan. Yeah. All right, here we go. Find all zeros. Whoo, how many answers does this one have? 5 answers. Can I factor that? Heck no, there's a lot of terms in there. So your go-to, let's graph this thing. Let's see how many answers we can find in the graph. All right, come on, guys. Let's go ahead and graph it. Y equals, clear out what you got in there. Half the time is spent just typing this thing in. I know it. You know, my older calculator, you don't have to, but then it's a lot more confusing because it doesn't pop them up in the air. So then it's harder to tell. Yeah, so be appreciative that it does it now because it used to be a lot harder. How many what? Tape? Yes? You're not really going to borrow it, are you?
If you want that.
All right, so looking at that graph, how many answers do I have just by looking at it? I have 3. Some of you caught on to that. Because what happened here? It bounced. Now, I'm going to caution you. I believe there's one on the homework assignment, which you'll do in class tomorrow after the quiz. But I believe there's one on there that looks like it bounces, but if you zoom into it, it actually doesn't. So be careful. If you go to use synthetic twice and it doesn't actually work the second time, it means it probably didn't bounce. Okay? But this one, I believe, actually does. Okay, so it bounces here, so that means -1 is an answer twice. And then my other answer is 2. Okay, so let's come back. All right, so x equals -1, -1, and was it 2? And 2. So I already have 3 of them. What's a good possibility about the other 2? They're probably imaginary, but it's possible that maybe 2 shows up 3 times. It's possible. All right, so set up our synthetic. So 1, -4, 4, 10, -13, -14. Again, if you're missing pieces, you'll have to put those zeros in. All right, I'm just going to go straight down my row. I'm going to start with -1. So synthetic, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. And you get excited because you get a 0 at the end, so you know it worked. Right? I got to do synthetic again. Aren't you glad you're not doing long division, though, with all of these? Nah, I'm really not. Synthetic is a beautiful thing. All right, so -1 again, because that answer showed up twice. Multiply, add, multiply, add, multiply, add, multiply, add. Is my multiplying and adding faster than yours? What's wrong? That's fine. Do -1 again, because you had 2 of them. That's okay. Totally fine. Nope. Nope, not a bit. All right, so then I'm going to use the 2. So multiply, add, multiply, add, multiply, add. Did you end up same place as me, Dawson? Yeah. Okay. Guys, just to kind of prove the point, Dawson did -1 and then 2 and then the -1 because his looked a little different. He kind of panicked, but when he went through, he still ended up same spot. So it doesn't matter the order. All right, so this one started x to the 5th. I did synthetic 3 times, so I'm down to an x to the 2nd. So this is x squared minus 4x plus 7, no remainder. We're going to set it equal to 0, and we need to solve this. Will it factor? No, it's not going to factor, so let's use the quadratic formula. All right, so x equals -b. Oh man, I'm telling you, this stuff comes back over and over and over. All right, so -b is 4 plus or minus square root b squared minus 4 times a times c all over 2 times a. 4 plus or minus radical, what do we get underneath there? Is that negative 12? Negative 4 squared is 16. I know 4 times 1 times 7 is 28, so 16 minus 28 is negative 12. That's the way my brain works. All right, and then simplifying our radical negative 12. So 4 plus or minus 2I radical 3. Good. You cannot do the shortcut. You got, no, it's not. It does not work. The shortcut can only be used when the cubes, the SOAP pattern, it's the only time you can use the shortcut. People, that shortcut does not work every time you do the quadratic formula. Think about it. Does the quadratic formula always end up with an I radical 3 on it every single time? No. Only in the cubes pattern does that happen. All right, all three numbers can be divided by 2. Good. 2 plus or minus I radical 3. Negative 1, and 2. Just remember that plus minus, that's 2 answers. 3, 4, 5. 2 plus or minus I radical 3, that's like a whole number. Yeah. Whoo. Yeah? So you just found 5 answers. No, we're not done yet. Why would we be done yet? All right, let's take a brain break, though. All right, here we go. Find all zeros. X to the 4th minus 9x squared minus 4x plus 12. Grab your graphing calculator, and let's type this one in. So y equals, cleared out. What's wrong, guys? Hey, guys. How about we just graph it and be done with it, all right? You're not the one I'm angry with at the moment. Hey, guys, take a look at this problem. How many answers did you find on the graph? It bounced, right? So negative 2, 1, and 3? How many answers should this problem have? It should have 4. You've graphed it wrong then. Hit y equals, look at your graph. Obviously not. Look at what you have typed in. Make sure you're probably missing something in there. All right, so guys, I found 4 answers. It's supposed to have 4 answers. So do I have to do synthetic or anything? No, I sure don't. Negative 2, 1, and 3. Yeah, 4 answers. I have 4 answers. Yay, done. Gotta like that. Moving on. Next one. How? It says I'm supposed to have 4 answers. I found all 4. Right? The graph. Bounce there, so that's 2. I got all the answers. Justin's up in his game. He did. He was done today. All right, here we go, guys. Find all zeros. We're almost done, guys. Hang with me. So again, let's go ahead and graph this one. Y equals. Guys, come on. All right, so on this problem, how many answers should it have? Should have 4. How many do I find on my graph? I found at least 2, right? Okay, so which ones did we find? Negative 2 and 1. Okay, So we found negative 2 and 1. So x equals negative 2 and 1. Let's go ahead and set up our synthetic. Is anything missing in synthetic? No. Okay, so 1, 1, 2, 4, negative 8. So I'm going to use negative 2. So go through your synthetic. We'll have to do synthetic with the other number. My basic math skills are strong. That's all right. That's all right. All right, so but make sure you're doing your kind of double layered synthetic. I started x to the 4th. You do synthetic twice, you're down to x squared. Okay, so when you're filling your x's back in, it starts with x squared plus 0x plus 4 equals 0. Do I need the 0x? No, I don't really need that one. So really I have x squared plus 4. So I'm going to subtract 4. So x squared equals negative 4. Square root. X equals what? Plus or minus 2i. Negative 2 and 1. Yeah, we're almost there. Almost through the week. Way to go, Perrysburg. Way to go, Perrysburg. We'll talk about that in a minute. Okay. All right. How are we doing? Doing all right? No? All right, we got 1 to go? Yeah, 1 to go? On your own, start to finish. Do you have any nice, pretty ones? Not really. Go back, hit y equals, and see what you actually typed in compared to what it should be. Double check it. Look for all your x's. All right, so when you graph this one, there it goes. It never actually crossed pretty, did it? Okay, so we know all the answers are real, right? They're not imaginary, because it does show all 4. But do I know what they all are by looking at it? I don't. Let's go through the calculate thing. Okay, so let's go through the calculate thing. Which one do you want to try to find first? The very first one? Okay. So remember, it's second trace. That pulls up your calculate. Which one do I want? The 0. So that's option 2. Now, if we're trying to find this first one, left bound, is it above or below? Above. Because if I be right from left to right, I would start here and start to draw. So from left side of it is above. So hit the left arrow. Sometimes it jumps faster than other times. Don't hold it down because then it'll shoot off your screen really far. All right, so left bound, I'm just going to do anywhere above is fine. Hit enter. It's going to ask for right bound. Hit the right arrow until it drops below the line. Hit enter. And we want to guess? Stupid, right? Just hit enter again. Now double check, because I have students all the time who will look at them like, I don't understand where it's telling me. And they still have guess on their screen. They never hit enter. The cursor should move to right where you wanted it to find it. So make sure your cursor is where you wanted it to go. Does anybody know what negative 1.732051 is as a fraction? I recognize it just because of my history with math, but that's a radical. If it's not a nice looking decimal, you're like, it's not pretty. So in other words, will that give me an answer right now that I can use? No, I can't use that. Okay, so let's try the next one. All right, let's try where it bounces, because that would give me 2 answers if I could find that one. Okay, so let's go second trace. Let's calculate again. Option 2. So now this one truly is left and right, because it never goes above the axis. So make sure your cursor is anywhere to the left of where it's crossing, and then hit to the right arrow until it moves to the other side of that vertex of it. There we go. Hit enter. Don't want to guess, so just hit enter again. Where did my cursor go? So negative 5.5000. Yours might look different than mine. Again, it's the pixels of the calculator and how like fine it is. What is this? That's negative half. It's negative half. Okay, so if you have like, anybody have like beautifully just negative 0.5 on your calculator? Did anybody get like a bunch of zeros and then a 1 at the end? You had a 3 at the end? Did anybody get 0.499999999? Yeah. Pixels in the calculator, what's stored in the history of it, how exact it is. It's just, I don't know. So that's negative half though, right? Do you guys agree? That's negative half? All right, so if we come back to this problem, x equals negative half, right? Since it bounced, I know that's 2 of my answers. And if I have 2 of the answers, and I know there's supposed to be 4, can I work with that? Will that get me to an x squared? Yeah, that'll get me to an x squared. All right, so let's go ahead and set it up. So 4, negative 11, negative 12, negative 3. All right, let's use negative half. What is negative half of 4? Negative 2. Add, we get a 2. Negative half of 2. Negative 1. That'll give me negative 12. What is negative half of negative 12? 6. That gives me negative 6. Negative half of negative 6 is 3. Gives me a 0, which tells me, in fact, that really is an answer. Okay, but we need to go again because I'm only down to an x cubed at this point. And that answer did show up twice. What is negative half of 4? Negative 2. Negative half of 0? 0. Anything times 0 is just 0. That gives me negative 12. Negative half of negative 12? 6. Negative 0. All right, so I started to the 4th. I did it twice. I'm down to an x squared. So 4x squared plus 0x minus 12 equals 0. Okay, do I need the 0x? Nope. So really I have 4x squared minus 12 equals 0. What's your plan of attack for solving? Yeah, I would use a square root method. Yeah. So 4x squared equals 12. Divide by 4. X squared equals 3. Good. Get square root. So x equals plus or minus radical 3. Negative half. Negative half. Grab your calculator real quick. Type in square root of 3. Do you remember that decimal that we found when we traced that very first one? Not an I. That's radical 3. Guys, take a look at that graph. This radicals come in plus and minus, right? Always? Always? So if you're looking here, there's the negative radical 3. What's that got to be? That's the positive radical 3. Why don't you square the answer?
If you square that 0.1, negative 0.1, whatever, shouldn't you get a whatever we just got?
Okay, I see where you're going. The problem with that is a radical, its decimal expansion continues forever. So your calculator is rounding it. It's only so many digits. So it's not going to be exact. Okay? All right, but that's kind of something to think about. When you trace and calculate for one of them and you get this weird decimal, that's probably a radical. And if you got the negative one, you're going to have the positive one because they come in plus minus. They come in pairs. Okay? All right, how are we feeling about all of this? It's a lot. What is necessary in order to do this assignment? Your graphing calculator.